Coronagraphs stationed across cislunar space are recording a striking chromatic shift in an interstellar visitor, 3I Atlas.
This morning we have a report that the object got much brighter than expected, and moreover, the color of the object is bluer than the sun. And that's very surprising, because usually when there is dust around an object, it should make it red.
Near perihelion, imagery that previously showed a green-dominated glow now appears blue-weighted, a transition that has drawn intense scrutiny from heliophysics teams and instrument specialists alike. The observation is visually dramatic, but it demands careful interpretation grounded in physics and instrument design. Under standard expectations, objects nearing a star often present redder integrated profiles as dust scatters shorter wavelengths and thermal emission rises at longer wavelengths. A sudden move toward blue dominance is therefore unusual for a natural coma and tail system.
The sun is 5,800 degrees Kelvin above absolute zero, and it's very difficult to keep a surface hotter than that. In fact, an object at the distance of 3I Atlas from the sun could only be 20 times cooler than the sun, so it should be redder.
Some analysts have suggested this could indicate very high effective temperatures. Others caution that coronagraph color channels, processing choices, and specific bandpasses can strongly bias apparent hue. In short, color in these images is a clue, not a thermometer. The physics backdrop is clear. Thermal radiation follows Wien's displacement law. Higher temperatures shift peak emission to shorter wavelengths. Lower temperatures shift it to longer ones. Cometary environments, dominated by dust and gas fluorescence, typically radiate primarily in the visible/near IR, with classic green features from molecules such as C222 and CN, plus red/IR emission from warmed dust. A transition from green-tinted fluorescence to blue-weighted imagery during intense solar exposure is, at minimum, counterintuitive and worth rigorous calibration checks.
Just want as much evidence as possible so that they would not be able to shove the anomalies under the carpet of traditional thinking. That's my motivation.
Right.
So I'm inspiring a debate right now, and there is a huge interest in that debate, so that we will collect as much data as possible so that by the end of the day, we'll figure out what our dating partner is.
On October 29th, 2025, 3I Atlas reached minimum solar distance. During the days around conjunction, the object was positioned behind the solar disk from Earth's perspective, effectively concealed since October 21, complicating direct optical tracking. Reported estimates placed incident power at 770 watts per square meter, a figure that has been cited in preliminary notes and should be treated as provisional until instrument-specific energy budgets are reconciled with geometry and distance. Precise values will matter here. Multiple platforms documented the evolution. Stereo A's coronagraph captured the approach phase from its heliocentric lead position, SOHO/LASCO at L1 provided continuous monitoring through conjunction gaps, and GOES 19 coronagraph data, introduced in 2024, resolved fine-scale envelope structure during the most challenging intervals.
The mass of the object tells you how much heat it can retain from the formation process, and then the surface area tells you how fast it can cool.
Cross-calibration among these data sets is essential because apparent color can shift with exposure curves, stray light suppression, and pipeline choices. Early season observations in August showed 3I Atlas with the textbook green-red mix associated with fluorescence plus dust. The perihelion phase imagery, by contrast, reveals blue-dominant frames that depart from expectations for a low-albedo, volatile-driven body. In public commentary, Harvard astrophysicist Avi Loeb has flagged this as a notable anomaly and posed a pointed research question. Could internal energy sources or non-standard heating be at play? That hypothesis would be extraordinary and therefore must clear an extraordinary bar of evidence. Two steps follow logically. First, instrumental and processing effects must be excluded. Verify bandpass responses, flat fielding, vignetting, and any algorithmic color mapping that could weight shorter wavelengths. Second, spectroscopy and photometry, even if indirect or from off-axis vantage points, should constrain the actual energy distribution rather than the perceived color in composite images.
Dr. Loeb, you were 4 out of 10. Has that number moved up? That this thing might be intelligent life and not just a big rock barreling through the solar system?
I think with the blue color, it's now a bit above 4.
Only then can temperature inferences be made with confidence. One geometry result is not in dispute. Coronagraph frames indicate a luminous envelope extending on the order of approximately 300,000 kilometers, approaching the Earth-Moon distance. That scale speaks to vigorous outgassing, significant dust entrainment, and strong solar wind interaction. Whether the blue dominance reflects real short wavelength emission, enhanced scattering from fine particulates, or pipeline weighting, the phenomenon marks a rare and instructive case study. In sum, discovery, then discipline. 3I Atlas presents a visually compelling deviation from typical cometary color behavior, but the path from color to temperature runs through calibration, spectroscopy, and physics, not impression. What this signature ultimately means will emerge from cross-platform analysis rather than any single frame, and that is exactly how science should proceed. The latest data aligns precisely with the massive carbon dioxide plume recorded in August. Fresh measurements now reveal brightness amplification far beyond what's typical for any known Oort cloud comet. Research teams remain cautious. While the evidence is compelling, the underlying mechanism still defies conventional explanation. At present, no established physical model accounts for the magnitude or persistence of this energy output. Across the globe, a network of distributed radio observatories continues real-time electromagnetic monitoring, listening not only for natural outgassing patterns, but for anything structured. Arrays scan for excess infrared emission, unusual trajectory changes, or repeating narrowband signals that might hint at propulsion or artificial modulation. Meanwhile, congressional oversight committees have begun facilitating the declassification of high-resolution imagery from October 2nd. Those files, captured at multiple wavelengths, could reveal surface or structural details not visible in the public datasets. These developments add yet another layer to what has become an extraordinary statistical puzzle. This 10th anomaly now joins a list of improbabilities that challenge the very foundations of celestial mechanics and materials science. First, the object's trajectory alignment within 5 degrees of the ecliptic carries a probability of only 0.2%. Second, the July-August ejection jets directed toward the solar center when all known comets exhibit the opposite pattern. Third, spectroscopy has identified a nickel-to-iron ratio that mirrors terrestrial manufactured alloys rather than cosmic blends. Fourth, its approach vector matches the 1977 WOW signal coordinates, 2 separate events 48 years apart, apparently sharing spatial origin. Fifth, the object's extreme dehydration, only 4% water content compared with the usual 80 to 90% seen in icy bodies. And sixth, the dramatic chromatic transition from green to blue emissions. Combined, these probabilities yield odds of less than 1 in 10 quadrillion, roughly the same as winning the world's largest lottery 15 times in a row. Now all eyes turn toward December 19, 2025, when 3I Atlas will reach its minimum Earth distance. Both the James Webb Space Telescope and Hubble will conduct synchronized observations. Webb focusing on infrared spectroscopy, Hubble capturing fine-scale structure. Dozens of ground and orbital instruments will coordinate in what promises to be the most comprehensive campaign ever directed at an interstellar object. Preliminary projections indicate enhanced luminosity as the object exits the solar vicinity, and the blue signature may strengthen further. Harvard astrophysicist Avi Loeb underscores that maximum data acquisition is essential. If this phenomenon stems from a technological origin, the implications would be enormous, and we must take that possibility seriously. Indeed, if 3I Atlas somehow generates or sustains temperatures above the solar photosphere, the engineering principles involved would exceed anything humanity has yet conceived. Natural bodies absorb and re-radiate energy, cooling in the process. Active systems, by contrast, emit sustained high-frequency light, potentially appearing blue if operating above 5,800 Kelvin. The distinction is fundamental. It separates passive thermodynamics from active energy production. No interstellar object has ever displayed this combination of traits. Oumuamua showed non-gravitational acceleration without visible outgassing. 2I/Borisov behaved conventionally, but 3I Atlas defies both categories. Its properties span from the highly anomalous to the seemingly contradictory. What makes this moment historic is its immediacy. The object is passing through our solar system now, within reach of modern detection networks, revealing characteristics that stretch our current frameworks of physics. In response, the global scientific community has mobilized like never before. Civilian and military sensors share telemetry. Universities cross-compare data in near real time. Even amateur astronomers contribute spectral traces to unified repositories. Together, they're constructing the most detailed multi-instrument record of any interstellar visitor in history. 3 analytical paths remain on the table: unknown natural physics, suggesting fundamental gaps in our models; extreme statistical coincidence, an unlikely yet natural confluence of rare traits; technological origin, evidence of engineered systems beyond our solar system. Any of these outcomes would be revolutionary. New physics would rewrite textbooks. An extreme coincidence would expose the limits of our assumptions, and a verified technological origin would answer one of humanity's oldest questions. For now, Stereo A, SOHO, and GOES 19 continue to monitor 3I Atlas as it emerges from perihelion. Every dataset, every photon matters. Embedded within these streams could be the clue that reshapes our understanding of cosmic behavior or our place within it. As December approaches, the world waits for clarity. We are witnessing scientific history unfold in real time, one anomalous blue photon at a time. If you've enjoyed exploring this mystery with us, make sure to like, subscribe, and join us again for the next chapter, because the story of 3I Atlas is only just beginning.